Hello friends. So in continuation with previous video on earth pressure and retaining wall, we are going to continue in this video and sum up different types of problems asked so far in GATE examination on earth pressure. So this is 2023 set 1. This is the retaining wall. The data are given. Height is 7 meter. Up to 3 meter, there is layer 1, which is a cohesionless soil. C is 0, phi 32, and gamma is given to you as 18. And the below there is layer 2, and here it is C5 soil. C is 20, phi is 25, and gamma is 19 kilonewton per cubic meter. And there is a surcharge also of 20 kilopascal. So you will have to find the active earth pressure at 7 meter. So I will make this problem quite simpler while explaining. Let's see how it can be met. So first of all, let's draw it. The solution will be like this. This is the retaining wall up to 3 meter, and for the remaining 4 meters. So this is 3 meter. There is another 4 meter. So here it becomes 7 meter total. So at 3 meter and 7 meter. This is the backfill. And I can take the reference line here. This is the reference line. And you can see that the value of for phi equal to 32 degree, phi equal to 32 degree, you can find out K1, which will be 1 minus sine phi upon 1 plus sine phi. So it will be 0.307. So you have got K1 value. And for layer 2, this is phi 1. So this is phi 1. And I can call this phi 2. Okay. So what will be the pressure at 3 meter? It's a dry soil. So dry soil means it is going to be due to the overburden, due to self weight, the pressure can be found out. So PA at 3 meter due to overburden, you calculate it. Surcharge we will calculate at the end. Okay, so it will be at 7 meter, we can calculate it. So PA3 due to layer 1 will be Ka1 into gamma 1 into H1. So this becomes equal to 0.307 multiplied by 18 multiplied by 3. So at 3 meter, Z equal to 3 meter, we can calculate it. So at 3 meter, if you calculate it, there is going to be the vertical pressure is going to be 54 multiplied by 0.307. So the pressure here, if I take the calculator and calculate it, there is 16.578. So here the pressure is 0 and the reference line has to be taken. So this is my reference line. The reference line is here. So here it is 0 and at 3 meter it is 16.57 kilopascal. So this becomes 16.57. Now the layer is changing. So if you go for layer 2, calculate K2, which is given by 1 minus sine 25 divided by 1 plus sine 25. So you can calculate this. So this will become 0.405 for phi equal to. So we have got, you can calculate it, 1 minus sine 25 divided by 1 plus sine 25 0.405. So due to the now it is C phi soil. C is 20. So at 3 meter, at z equal to 3 meter, due to cohesion, what will be the pressure? The pressure is going to be minus 2c under root K2. Negative pressure will develop here, and this negative pressure plus there is a overburden. How much is the overburden? It is 54. So vertical pressure is 54 at, so this vertical pressure 54 multiplied by K2 is the total pressure at this level. So we can calculate it, 0.405 into 54 minus 2 into the value of C is 20 multiplied by under root 0.405. So this is giving you minus 3.539, means 54 we can take it. So here it is a negative pressure. So the pressure here is negative. And this negative pressure at the top is going to be 3.54 kilopascal. And this is the value of Z naught from here to here. Z naught will be 2c divided by gamma 2 under root K2. So let's calculate it. This becomes 40. And here there is 0.405. So Z0 can also be found out. So this Z0 will be 40 divided by 19 into 0.405. So you can calculate this quite easily. So then this can be calculated in meter, right? And if you go further at 7 meter, so at z equal to 7 meter, that is what in the question is, what will be PA at 7 meter? So PA at 7 meter will be PA7 equal to minus this value 3.5 That is, we can take it minus 2c. Let's take it like this. Minus 2c under root K2, right? And plus K2 gamma 2 into H2. H2 equal to 4 meter. So for this will be there plus 54 into 0.405. Now this and this value comes together as minus 3.54 plus K2 is 0.405 multiplied by gamma 2 multiplied by H2. So this value is this. So finally, if you calculate it, this becomes 0.405 multiplied by 27.24 kilopascal. So we have not taken into consideration this effect of this surcharge Q. Now taking surcharge Q equal to 20 kPa, PA7 due to surcharge or PAQ due to surcharge can be calculated. PA7 will be at 7 meter. It will be K2 multiplied by Q. So 0.405 multiplied by surcharge is 20. So 20 multiplied by is 8.1. Therefore, total active earth pressure at 7 meter will be due to surcharge, that is 8.1, plus due to overburden, and that value is 27.24. This is due to overburden. So plus 27.24, 35.34 kilopascal. So this problem has been, the pressure here is going to be 35.34. So we can get the net pressure at 7 meter. So due to surcharge, you can calculate it separately, K2 into Q, very simple way. You can find out at 7 meter. And due to overburden, so this part is due to overburden. So first part and second part add up together to get the answer. So this is the answer. I hope I have made your point quite clear. Now, we will take up another problem. Such layered backfill soil mass has been consistently asked in the examination. So you should be very clear about it. And now I am going to have another problem which was asked in 2021 set 1. Here, for a retaining wall of height 10 meter, the following data are given. Data given are the backfill is clay, and the value of gamma for this clay is given to you as 17.2 kilonewton per cubic meter. Then they have given you the value of phi is 0 and C is 30 kilopascal. The depth of clay in front of retaining wall is also given. Depth of clay in front of retaining wall is given as 2 meter. So this is 2 meter. And the tension crack which gets developed because the clay is backfill soil you have used as clay mass. So this tension crack is filled with water. So this is also given, and the unit weight of water is also given as 9.81 kilonewton per cubic meter. So using Rankine's earth pressure theory, find the factor of safety against sliding failure. Sliding failure of the retaining wall. After ignoring passive earth pressure, and we have to take delta equal to 20 degree. This 20 degrees between base of the wall and clay. So this is between base and clay. So that is the value of delta. It is given as 20 degree, and the weight of the wall W is given to you as 5000 kilonewton. So very simply you can draw the retaining wall. So this is the back of the wall, this is the front of the wall. So here in the front you have got the clay of 2 meter, and the height is going to be h equal to 10 meter. So this is given, and the unit weight is given to us as 17, and C is given this much. Unit weight of water is given, and there is a tension crack also, which is filled with this one. So the depth of tension crack, you will have to find it out, and because it is sea soil, the cohesion value will be how much, and depth of. So solution of this problem is quite simple. The cohesion will be at z equal to 0. The active earth pressure due to clay soil will be minus 2c under root k. Here, because phi is 0 degree, k is going to be 1. So this is going to be minus 2 into c is 60 kilopascal with negative sign. So if you take the reference line, this is going to be minus and minus 60 at z equal to 0. At the very top, there is given to you the pressure, right? And z0, where Pa is going to be 0. So this becomes Pa is going to be 0. So this is z0 is going to be 2c divided by gamma under root k. K is 1. So it becomes 2c means 60 divided by gamma 17.2. So take your calculator and calculate Z0. So Z0, I can calculate it. 3.488. 3.488 meter. So this is 3.488 meter, right? So Z naught is also find it out. Now, what will be the pressure at the bottom? So at Z equal to H, Pa will be minus 2c under root k plus gamma z, that is gamma into remaining part. From here you can find it out. So the vertical pressure is going to be gamma into H multiplied by K. So that K is anyway, it is going to be this. So this becomes, already it is calculated as minus 60 and K is 1. So the vertical pressure at H, gamma z, K gamma into Z. So gamma into H, gamma is given to you as 17.2 and the value of H is given to you as 10 meter. So this becomes 172 minus 60. 172 minus 60 equal to 112. So 112 kilopascal. So PA at 10 meter is 112 kilopascal. So this is how the pressure distribution. So here it is 0. So this part is positive. So therefore, and this is going to be, this is the reference line, this is negative. So taking the positive part, you will be getting the active earth pressure. Now, active earth pressure will be half into 112 into 10 minus 3.488. So half into base into height is 10 minus this plus. Now up to Z0 there will be tension crack because soil cannot resist this. So there will be tension crack. So in this part there will be a tension crack. So this part you can show that there is a crack here and it is completely filled with water. So plus this will also add further pressure on your wall. So this will be gamma W into Z0. So gamma W is given in the problem as 9.81 and Z0 we have computed as 3.488, right? So this is going to be additional pressure due to crack and getting filled with this. So this becomes 56 multiplied by 10 minus 3.488 plus 9.81 into 3.488. So PA is going to be 398.88. This is going to be the pressure. So the pressure is going to be this. So what will be this? You can find out the force multiplied by 0.5. So gamma W into Z0 is the pressure over here due to water, and it is going to be a triangular variation. So half gamma W ZW whole square. So here you make it a square, and gamma W will be this one into 0.5. So this is the correction. So please make this correction also. So I will be taking this one once again, 56 multiplied by 10 minus 3.488 plus 9.81 into 3.488 whole square into 0.5, well, 424. This gives me 424.346 kilonewton per meter length of retaining wall. So this is the net value of PA. So PA, which is acting over the wall, equal to 424.34. So this is known to us. Therefore, what is to be found out? Factor of safety against sliding. So factor of safety F against sliding will be, due to this weight of this, the weight is given to you. So mu times W will be, when you are trying to push it, the frictional force. So this will resist this active earth pressure. So mu times W divided by PA, that is the factor of safety against sliding. Now mu is tan delta, and delta is already given over here as 20 degrees. So tan 20 degree multiplied by 5000 divided by 424.346. So this will be the factor of safety. So let's calculate, friends. It will be tan 4.288. This is the factor of safety. So this is the answer. So this answer is quite simple, but you will have to, like here, normally you have to take the force, but sometimes if you by mistake, if you take gamma W into Z naught, then you commit the mistake. It will be half gamma W Z naught square. So water is filled up in this zone, and the pressure due to water in the tension crack is this part, and the remaining due to overburden you have already calculated. So sum total it is 424.34, and everything we have been able to calculate. So this is the answer. The question was factor of safety against sliding. So answer is 4.288. This is the factor of safety against sliding. I hope you have understood this problem also very nicely. And then we will move to the next problem now. The next problem is also quite simple. It is 2018 set 2. So another gate problem we are going to have. There is a wall, and there is a wall having height of this retaining wall is of height 3 meter. So this is the retaining wall. Having the dry granular soil as backfill. Granular soil. This so its gamma is 20 kilonewton per cubic meter, and the value of phi is 30 degree. And this wall is unyielding. Like if you take a gravity wall due to huge weight, it doesn't move at all. So wall is unyielding. This is very important. Please keep it in mind that if the wall is unyielding, it will give you earth pressure at rest condition. This will lead to earth pressure at rest condition. So if it is earth pressure at rest condition, then you need to find out in this question, find P naught. So what you will have to find out? The lateral pressure, lateral force, lateral thrust. This is the lateral thrust at rest condition. So you will have to find out this one. So very simple problem that has been, with the given data you can easily find it out. So what will be the value of P naught? The wall is not going to move at rest. So K naught into half K naught gamma H square. And this can be further written as half. K naught will be for dry granular soil 1 minus sine phi, that is sine 30, and gamma is 20 and height is 3. So much of kilonewton per meter length of the retaining wall. So let us calculate it. This becomes 0.5. So 0.5 into this also becomes 0.5. And this becomes 20. This is 20. And this is 9. 45. This is equal to 45 kilonewton per meter length of retaining wall. So very easily we could sum up this problem. I hope nobody can have any doubt about this. So P naught we have been able to find out. P naught is 45. So if wherever you get the unyielding wall, you can do it like this. Let us go to the next problem now. Now the next problem we will take is of 2016. And this is of set 1. In the figure, they have given you the figure. The figure looks like this. The figure is self-explanatory. There is the retaining wall. And this side is the backfill, which is phi soil. And the weight and this width is uniform 4 meter, and the height of the wall is given to you as 6 meter. So H 6 meter, and it is given that the active earth pressure at 6 meter equal to 40 kilopascal is given. So here at 6 meter depth is given. So what you will have to find out then? Find minimum weight of the wall. Find the minimum weight of the wall required to prevent from overturning. This is the question. Very simple question. This one. The factor of safety solution we can see. The solution, the factor of safety against overturning, this is the two. So if you are going to take the overturning, then this will be resisting moment upon overturning moment. So resisting moment will be due to weight, and overturning moment will be due to lateral thrust. So here, because it is a phi swell, what will be the pressure distribution for this wall? For this wall, the pressure distribution is going to be triangular. And this pressure is given to me as 40 kilopascal at 6 meter. Therefore, I can calculate the area of this pressure distribution diagram, PA, which will be half into base, that is 40 multiplied by height. So this becomes 120 kilonewton per meter length of the wall. So this is the value of PA. Now, the resisting moment MR is due to the weight, as I told you. So the weight multiplied by X bar. What is the value of X bar here? From CG up to the toe, it is 2 meter. So this is the weight multiplied by 2. And the overturning moment is due to this pressure, which will be acting at H by 3. So H by 3, that is 6 by 3, that is 2 meter. This side. So PA location is known to you. So overturning moment about the toe is going to be 120 multiplied by 2, that is 240 kilonewton meter. Therefore, the factor of safety equal to 2 times W MR divided by 240. Now, for F equal to 1, W equal to W minimum, critical value. To prevent, the minimum weight of the wall required is to prevent from overturning. So now 240, therefore if you substitute, then 240 into 1 factor of safety equal to 2 multiplied by W minimum. Therefore, W minimum equal to 120 kilonewton. This is the answer. So friends, you have seen that in GATE examination, how the questions are being asked. So the minimum weight, W minimum, equal to 120 kilonewton per meter, of course, per meter length of the wall, kilonewton per meter length. So 2016 problem. Now the next is going to be 2015. So another problem. Is going to be now quite simple. Again, 2015 set 2. There is another problem. Surcharge loading required to be placed on the horizontal backfill, of a smooth retaining wall. So as to eliminate tension crack. Right? So if you want to remove the tension crack which comes in Siphi soil or purely cohesive soil, you know that for any Siphi soil, what is the tension at the top? At Z equal to 0, that is at the top of the backfill, the tension developed, that is PA at Z equal to 0, will be minus 2C under root K. Right? Now, the question is here, if you want no tension crack, for no tension crack, what should be the surcharge Q? So surcharge loading Q required to be placed on the horizontal backfill. So if you have a retaining wall here, this retaining wall here, you will have a tension crack. So this tension crack has to be eliminated. To eliminate this tension crack, you need to place the surcharge. Now, if you place the surcharge Q, What becomes the pressure? The pressure from top to bottom is going to be the pressure at Z equal to 0 due to surcharge Q, PA Z equal to 0 due to surcharge will be K into Q. So if you equate it so that this 2 becomes equal. If this is negative, this is positive. When both are going to be equal, it will nullify. There will be no negative pressure. And if there is no negative pressure, there will be no tension crack. For no tension crack, this minus 2c under root k must be equal to k times q. So what is the this value? What is the value of q? So here you will have to find out the value of q, surcharge loading required. Therefore, q magnitude will be 2c divided by under root k. So, friends, this is the required surcharge. This is the required surcharge for no tension crack. No tension crack. So this is the answer. I hope this problem is quite simple and you must have understood it. Now, the another problem, we are going to take it, and this is the last. I have taken all the varieties of problems asked so far in the GATE examination. So 2019 set 1. What this problem says about. You have a wall and the back is smoother, smooth back, and the backfill is inclined with the horizontal at an angle beta as shown in the diagram. So you will have to show the direction of active thrust PA, active thrust, not pressure, but active thrust on the wall and its location. This is the problem asked in GATE 2019. Now, because the back is a smoother one, there is no friction, delta will be 0, and therefore here PA will be inclined with this horizontal at the same angle, and its location y bar will be h by 3. So location is h by 3, and we have shown the direction of PA. So this is the solution of this problem. Friends, I have taken all the varieties. Other questions are repetition of these. Layered soil also we have taken, uniform soil we have taken. So with this chapter is completely over. You can have good practice and you can fare well in the examination. So these tips which I have given you today will go a long way in making your concept clear. Thank you very much.